Good afternoon, folks. This is Mike coming back at you with another video on Intro to Algebra. In the previous video, we talked about the multiplication or the multiplicative property of equality and how we can use that to solve linear equations in one variable. In this video, we're going to see how we can take that property as well as the adding property of equality and use both of those within the same problem to solve some slightly more complicated linear equations in one variable. So we can apply both the properties that we learned to solve linear equations in one variable. And when we do so, we have sort of a common process that we typically use. You'll definitely want to follow this process for any kind of linear equation in one variable that you have to solve. First thing you want to do, though, is simplify each side separately. Distribute constants in and multiply things out, combine like terms, do that with each side on its own. Make things cleaner, make things nicer to work with. Don't work with stuff when they're ugly, work with stuff when it's nicer. Once you've done that, add or subtract things so that all terms containing the variable, could be x, could be t, could be y, could be whatever, are all on one side of the equation. And then simplify, combine those like terms. Once you've done that, add or subtract so that all the constants are on the other side of the equation, the side that does not contain the variable. Once you've done that, then simplify that side, combine those constants, get it down to one number. And then you're going to solve for x. You're just going to, at this point, pretty much use the multiplication property to solve for x. Multiply both sides by something or divide both sides by something, but just have x left over on one side of your equation. And then lastly, this is always a good habit to get into, check your answer. Substitute the value that you found back into the problem at the very beginning and make sure that the equation does indeed hold true. If it doesn't, then go back through the problem, rework it, or check that you didn't make some kind of mistake when you checked your answer. So we're going to go through this process with some sample problems here. First one, 2x minus 1 equals 5x minus 10. These sides on their own are as simplified as they can be. Just looking at the sides on their own, no like terms, no like terms. All right, so now I'm going to move things so that I have all of the x's on one side. Now, it doesn't matter which side you put the x on and which side the constants go on. Does not matter. Do whichever one you like most. I personally, though, am going to choose to get all the x's on my right-hand side. So I want to take this 2x and get it to vanish from the left-hand side. So how do I do that? Well, if I subtract 2x, then I'll have 2x minus 2x. That gives me 0. But what I do to one side, I do to the other. So I'm going to have, after those are gone, I'm just going to have negative 1 equals, I have a 5x and a minus 2x. I'm going to combine those because those are like terms. And that's going to get me 3x minus 10. And I'll just rewrite that up here so we have more room. Now, I need to get all the constants, all the numbers, just numbers, no x's multiplied onto them, all the constants onto the other side. So I need to get this guy gone from here and see what results over here then. So how do I clear this guy out from the right-hand side? Well, I can add 10, and that clears it out. And then what I do to one side, as we know, I have to do to the other. So those will just cancel out to 0. And I have -1 plus 10, which is 9. So I have 9 is equal to 3x. And now I just want to solve for x. Just want to get the x all by itself on this side. How do I do that? Well, here I have 3 times x. So if I divide by 3, the 3 and the 3 divide out to 1. But then, as we know, what I do to one side, I have to do to the other. So x is 9 over 3, or 3. And now, as your check, take this x value, substitute it into both sides of your equation, and make sure that the left and right-hand sides are indeed equal. So you can label this check, or you can just do the work on the side. 2 times 3 minus 1 is going to equal 5, using our order of operations. And 5 times 3 minus 10 is going to equal 5 as well, from using our order of operations. Clearly, these things are equal, so the equation does indeed hold, and we know that our answer makes sense. All right, moving on to the second one here. We have -2 times the quantity, x plus 1, and then another plus 1, and that's equal to 5x. All right, this left-hand side can be simplified more, so let's take care of that. I'm going to distribute the -2 into these two terms to give me -2x minus 2. I still have my plus 1, and that's equal to 5x. And then I can combine the -2 and the plus 1 to give me -2x minus 1 is equal to 5 over x. Okay. Now that we have each side simplified, now we get all the terms that contain the variable, the x, onto one side. I'm going to choose to move all the x's onto this side here on the right side. So I need to get rid of this guy. I do that by adding 2x, because I have a -2x there. And then, as we know, what you do to one side, got to do to the other. So that gives me -1 is equal to 5x plus 2x, or 7x. I already have the constants all by themselves on the other side, and they're combined, so that's good. Now we just need to solve for x. What am I going to do to both sides? Well, here I have 7 times x. Divide both sides by 7. Those divide out to 1. And this divides out to x equals -1 over 7. Now, checking our answer. -2 times -1 over 7 plus 1, and then plus 1. Well, 1 in terms of sevenths is equal to 7 over 7. And then if you add a -1/7 onto that, and you can check this by plugging this into your calculator as well, is going to give us -6 over 7. And then I have a -2 times the -6 over 7. Oh, sorry, my apologies. That's going to be a +6 over 7. -2 times the +6 over 7 gives us a -12 over 7, and then plus 1. And then adding these two, you'll find that you get -5 over 7. Again, you can verify that by plugging that into your calculator. And now verifying the right-hand side. If I do 5 times negative 1 over 7, that gets me negative 5 over 7. These two things are equal, so huzzah. This is indeed our solution. Try one more here. We'll do the third problem and the fourth problem. I'll let you try it on your own as a little bit more of a challenge. Here I have 1/2 times the quantity 3x minus 4 is equal to 2 times the quantity negative x minus 3. In this case, we can simplify each side on its own, and we can do some simplification with both pieces of this. So I'm going to distribute the 1/2 into each of those two terms. It's going to give me 3/2 times x minus, and then 1/2 times 4 is 2, equals, and I'll distribute this 2 into each of those two terms. So I have 2 times negative x, or minus 2x, minus a 2 times 3, which is 6. Okay, each side is simplified. Now, let's get all the x's onto one side and all the constants onto the other. This time, change it up just a little bit. I'll get the x's over on my left-hand side. So what am I going to do that? As you probably guessed, I'm going to add 2x. Those add to 0 there. And now I have 3/2 x plus 2x. If you do 3/2 plus 2, you get 3.5, or 7/2 x. Minus 2 is equal to negative 6. And now I want to have just constants on my right-hand side. So to do that, I'm going to add 2 to each side. And negative 6 plus 2 is equal to a negative 4. So now, solving for x, I'll divide by this fraction, divide by 7/2, and divide by 7/2. These divide out to 1. And again, we're dividing by a fraction. That's the same thing as multiplying by the reciprocal. And that is going to give us negative 8 over 7. And as a fun little exercise in terms of working with fractions, I'll let you check that one on your own. This definitely is the answer. It's definitely a solution, but a bit more of a challenge for you. Try to verify this one on your own. You can see that we're not always getting really nice numbers, really nice values for these things. And that is something that you may have to start to get used to if you're used to seeing nice numbers as answers. Solutions to equations aren't always nice values. So do the check on your own there. And I challenge you guys to do the fourth one here on your own and see if you can come up with the answer. All right, guys, so that concludes our video on section 2.3. If you have any questions or comments, please be sure to reach out to me, stop into the office hours, send me an email, give me a phone call, whatever you need to do, Otherwise, until the next video, take it easy, guys.